from the book. It says,
I do not have the folder. Nope. I don't have access to the folder. Too bad. I do not have access to it. Double checking to make sure that we don't have answer keys or something. What? Oh. So I tried downloading it, and I'll do it again, but it's not going to work. Doesn't work. So, yep. Okay, that's pointless. Let's just delete that. The only way you can do the problem is if you have the data set. Number 2. Let's see. Another one that provides data. Doesn't work. Can't do number 2. Try again. Can't do it. Skip number 2. Number 9. Great. Oh, what? How many questions are there here? There's no way there's this many questions. It might be this many questions. Let's see. Why? Oh, man. We have number 9. Right. Looks like number 9 we can do without a thingy. Man. We can do number 9, I believe, without a full file, but let me just double check.
It's a random sample of 100 light bulb lifetimes ALT tests. And so our
dang.
5%
Going really fast.
I like tricking better.
Number 2.
Tricking Excel into doing a 1 sample test by making it think that it's a 2 sample test. Okay, I hope that's not too confusing. If it is too confusing, reach out to me. We can handle it. So the next one is number 11.
No! Are you kidding me? Are you kidding me, dude? Dude, what? You've got to be kidding me. You just got to be kidding me. The one problem I actually can do.
Director of Admissions of a distinguished MBA program is interested.
Dang it. Seriously? Oh, come on. Now I have to actually look up how to do the problem. I was not under the impression that I would have to do this. Gotta be kidding me. You have got to be kidding me. In the past, 60% of all undergraduate students enrolled at a state university earned their degrees in 4 years of matriculation. What does that even mean? basically null. $40 out of $95. 40 divided by 95. That's a significantly lower amount. Given the sample outcome, calculate a 95% confidence interval for the relevant population proportion. Don't know how to do this. So a number was 60%, now it's 42%. You know what? We're going to change these to just 0.6. Just plain numbers. Okay, so this is basically the same thing. The hypothesized proportion. Oh my gosh. Oh my gosh. They think it could be this. They got a result of this. H0 is that the proportion is more than or equal to 0.075 versus HA, the proportion is less than 0.075. So what do we got? What do we want? What we want to prove is that the proportion of 60% is true. Or we want to prove that it's not true. If it's the status quo, it'd be 60%. Is it going to be 60% or more, or what? We want to say it's 60% or more, and then the alternative is that it's 60% or less. So, is that really it? What they are proving is that they're trying to prove, they want theirs to get from 0.15 to 0.075. The null hypothesis is that the proportion is more than or equal to 0.075. And their hypothesis is that it's going to be less than 0.075. If we're taking a similar approach here, if it has changed, that means it's going to be less than 60%. If it has not changed, it's going to be 60% or more. The null hypothesis is that it's more than or equal to 0.075. And the alternative hypothesis is that it's less than 0.075. Okay, so we're going to say, no, what we're going to do is null is going to be P is more than, P is equal to or more than 0.6, P is less than 0.6. That's how we approach. Probability that, or the proportion is more than or equal to 0.6, and the alternative is the proportion is less than 0.6. That's what we're doing. So, let's just compare it with this. Type of alternative hypothesis. One-tailed less than. That's what we want. One-tailed less than. So, and the sample size is what in our case? Sample size is 95. We have number with property of interest. In their case, they have number who graduated. We want number who graduated. So we have number who graduated is going to be what, 40? 40. So and then we want, so the sample proportion is equal to basically this divided by this. So so there, standard error of proportion. So standard error of proportion. Now we need to use some kind of formula here. We want square root of something times something something or something. Wow, that's fun. So we have square root B3 is the hypothesized proportion. Hold on. So the hypothesized proportion is 0.075. We want less than hypothesized proportion is, it's weird how this works. It's weird, but it's 0.6. We want less than 0.6. So it's not that it's the probability that it's going to be 42%. It's the probability that it's less than 60%. So less than 60%. So equals square root. We're going for less than 60. They're going for less than 0.075. So we have this times parenthesis 1 minus the proportion divided by the sample size parenthesis. So square root B3 B5. Wow, that was the exact same. Sample size. Dang, it ended up being exactly. Now we test statistic z-value. So this could be complicated. Nope, it's not. It's very simple. All you do is equals parenthesis. Well, now what is B7? In their case, it's the sample proportion, and that's the same with me. So the sample proportion minus B3 is the hypothesized proportion. That hypothesized proportion. So this parenthesis divided by the standard error. So now this is looking like something here. This way. So we have p-value So this is interesting because this is telling us how to do it if there's like different scenarios. We just want one tail less than. We want one tail less than because that is so less than one tail less than. If B2 one tail less than. What on earth? What? This comma 2 times this stuff. What is this? What do you do here? No. What is all this stuff? What is all this stuff? It's norm.s.dist. It's 2 different things. If parenthesis, comma, something, 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 norm.s.dist. Okay, I think all we have to do is 2 times all this stuff. What? What? What is ABS B9? What is all that stuff? Wait. Do we just have to do the third thing here? Just the third? Are we supposed to do this last line? Nothing, all this other stuff is just extra? Dude, look at this. If B2 equals this, norm.s.dist, B9, comma, true. Gosh. What are we supposed to do here? What are we supposed to do? Which one? I don't want to type all that stuff. I mean, I could do that, but... Which one are we supposed to type? Explain what we're supposed to type in this. Because they're giving you like every single possible scenario. Screw you. You really gave us all of this extra stuff. You didn't explain what we do if it's just simply this. Which one are we supposed to type? If B2... If this screw you textbook. Gosh, now I have to look up a video. I have to look up a video now.
Welcome to Excel 2010 statistic video number 86. Hey, if you want to download this workbook, Business 210 Chapter 9 second file, click on the link below the video. And this is our last video for Chapter 9. We got to do hypothesis. This code will show respondent immigrants and others. At alpha, 0.01 action will be held. A population sample that really other functions we have to, we'll see them yes or no. Trials are independent, we'll assume that they are. Each trial results in a success or a not success. Yes, well, what is a success going to be for us? It's going to be answering yes, I do know. Not have these 4 tests, but then there's 5, 6. You have to have one. And hypothesis, we know. We got to look at the point of view, the goal. The high. Type 1 error is we have yeses and the nos. So yes, we're going to use the function count if. Count of each other, so I'm going to click down. Yes function. We have our 0.2368. That'll be our p bar. We have to calculate standard error, and so it's p times there's proportion. Proportion is the z distribution, so that's 2.9, almost 3. Standard deviations above. You can already guess. I mean, this is the 7th or 8th test we've done in this chapter. That's way above. 3 standard deviations above, so we're probably rejecting the null and accepting the alternative. Let's go ahead and calculate our p-value. Now, if we calculate a p from this is on the upper end, and we want the probability above it, so we have to do 1 minus, and back to our norm dot dist. The dist goes from some value to some probability. Oops, I picked the wrong one. I have a z here. So I need my s for the standardized normal distribution. So there I have my z, comma 1 cumulative. It'll calculate all the way up to this, which is a lot, and then 1 minus that will give us our probability. So this value here is amazingly small, which means it gives us very strong evidence that we should reject the null and
I don't know what ABS, all that ABS stuff is. Is that really necessary? What is the 2 times all that crap? Like, is that even needed? Norm.dist B9 true. Probability less than this. Like, what is the 2 times 1 minus blah 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 blah? Is that like two-tailed or what? So I'm just gonna hope that this stuff is not needed. Dang my life, that was funny. So we're going to be doing norm.s.dist norm.s.dist this one comma true. That's not what we're trying to do. Darn it. How do you calculate the 95% confidence interval? I accidentally did B instead of A. This is hilarious. I accidentally did B instead of A. What was A? How are we supposed to do A? You have got to be kidding me. Where am I supposed to find how to do this problem? You know what's hilarious? This is from chapter 8. The thing that they're asking me to do is from chapter 8. Because it's confidence interval for a proportion. That's what we're doing. Let's do something from chapter 8 now. Yay! Okay, so what we want, I think we just got to do this. Okay, let's move all this over to somewhere else. That was B. A is, we're looking at this, confidence level. Sample size 95. Number who graduated 40. Sample proportion standard error proportion. Well, it looks like we already calculated that because it's square root of the sample proportion times 1 minus the sample proportion divided by the sample size. So we've already calculated that. So oh, come on. Now we look at multiple, which is different. That was funny. It's funny, I did B first. Hilarious. Yeah, because I didn't expect that we would have to do something from chapter 8. Norm.s.inv. Six or higher. Norm.s.inv. So B2 is the confidence level. So 0.95. Parenthesis 1 minus the 0.95. Divided by 2. Well, that's fun. 0.95 plus. Isn't 0.95 plus 1 minus 0.95? Are you freaking kidding me? Is 0.95 plus 0.05 divided by 2. Okay, I get it, because that's basically 90. That's like that, and then that was fine. Dude, like, lower limit, you do the sample proportion minus the multiple times the standard error, and then, okay. So equals the sample proportion minus the multiple times the standard error. And then equals this plus this times this. And there. Save. And that's okay. That's funny. So this suggests there has been a change because 60% falls outside this sample. We have done number 9 without any help. Well, we had help, but from some stuff, but we're not without help from the instructional video that randomly skipped number 9. So there, it was fun. That took me 42 minutes. That took 42 minutes. Are you kidding me? That was fun. That took 42 minutes. It took 42 minutes to do one question. One question. That took forever. That was funny. 11. Let's see if I can download it. I can't. Fun. Do I need that to download? Yes, I do. Yup. Do I do need it, so I can't do 11. Number 15, can't do it. 15, let's see here. Yeah, we can't do 15. How about 17? Nope. 17, you need the data for that problem, you can't do it. Number 19. Yes, you do need the data for 19, so it won't be able to do that. Number 21. Like, what is this, dude? 21. And yes. So there you go. We can't do that one. Last problem. And nothing. 23. Fun. Yeah, we can't do any more problems today. That's funny. I did number 9. Well, that is awesome. That is just awesome. This is going to be delayed even more. How did nobody realize that? Did nobody complete this assignment? Because you can't download a single file. Not a single file can be downloaded. This is ridiculous.